Hey everybody! Do you remember the simulation of an old CRT monitor I created about a year ago? We had programmed various issues and imperfections characteristic of these devices, such as white noise, rounded corners, ghosting, and so on. This time, we'll simulate a more modern device, an LCD, with its typical pixel grid and less vibrant colors. Unlike CRT, such a shader is elementary, as we'll see right away. And once again, we'll create an effect that processes the entire screen, or at least the background image. So I will set up the usual scene with a screenshot from our game and configure everything necessary for programming the shader. Right click, create a new scene, LCD, okay. Click, and the texture is right here. I'll drag it to the scene. So it created the sprite 2D node automatically, and in the inspector I will fix the offset. It should not be centered, and in transform position I'll reset position to 0, 0. Okay, and of course we need to set up the material, which will be the shader material. Click and new shader, which would be called LCD shader of the canvas item type, and I'll put it as usual to the shaders folder. Create and click again to open in the editor. Expand, and as always, we can delete everything we don't need from the generated code, leaving only the fragment function. Deleting vertex and deleting the light. Very well. So, as I mentioned, the shader is simple to program, and the code will definitely reflect that. Let's put it together, starting with the uniform parameters. Okay, uniform, float, stripe. I'll get to the explanation right away. Int range, and the initial value would be 0.5 to range from 0 to 1, and 0.01 as the step, and the second one, uniform float scan, hint range, and 0.5 again, and the same hint range, same step. Okay, so what do these parameters represent? Under the name stripe, we define the base gray shade of the vertical lines, where we will periodically set the red, green, and blue components to the maximum value of 1. As for the parameter scan, it represents the gray shade of the horizontal lines, which we'll set for every third pixel in the vertical direction. The actual code in the fragment function will do exactly this. Let's start by implementing it. So, in the fragment function, let's create a vector for color, which is simply the value of our texture, texture and UV. This time we won't be doing any transformations of the UV coordinates, so we can simply use the internal UV without creating the lowercase UV as usual. Okay, the second line, vector 4, we'll call it LCD. This is exactly what would create the effect, is vector 4, and our stripe uniform parameter used 3 times for all color components, and the alpha value is 1, sorry. And finally, int RGB stripe is integer of modulo. Again, I will get to the explanation right after writing this line. Frag chord x modulo by 3. Okay, so we have something new here, or not entirely new, but something I haven't used in a tutorial for a long time. It's the variable frag chord, which represents an alternative coordinate system. Why is this useful? Unlike the UV coordinates we usually use and which are normalized to the range from 0 to 1, frec coord contains the coordinates of the current pixel, which are not normalized. In our case, the x-coordinate will range from 0 to 600, while the y will range from 0 to 400. This makes it easier to determine whether a pixel belongs to the first, second, or third column, or their integer multiplies. Another interesting thing about this code is the conversion from float to int, this function. It was necessary to work with integers because the mode function applied to floats doesn't always return values like 0, 1, and 2 in this case, which would make the subsequent conversion much more difficult. With integers, it is straightforward. Okay, so we can now perform the conversions and display the result. Let's insert the following lines right after this code. Basically, we'll determine which color to set based on the result of the mode function, which would be 0, 1, or 2, and then multiply the original pixel color by this modified value of the LCD vector. So if RGB stripe is 1. Let's start with 1. LCD dot R, a red component, is set to 1. Else if RGB stripe is 2, we will set LCD green component to 1. Else, which means that it was 0, the result is the RGB stripe, LCD blue component is set to its maximum value. Okay, and finally we can assign the final color to the internal variable color, and we can just multiply color by the LCD value. Let's wait for it. Okay, let's take a look at the zoomed in section, because I suppose this is not too much visible in YouTube. So for example, this part with the lamp, we should be seeing these vertical stripes. I'd say the vertical stripes are fine. So what remains is to add the horizontal ones, which only need to be set on every third row to make the resulting grid uniform. We'll add the following code just before the final assignment of the color variable, so right after the vertical stripes. So if, again, casting to integer, modulo of frec coord, and this time we are working with the y coordinate. Again, we are dividing by 3. So if the modulo is 0, let's add the horizontal scanline LCD RGB to all components. So it would be a gray line, vec3 of the scan value. Wait for it. Okay, can you see the grid? If we want to disable the entire effect, we'll just need to set both uniform parameters to the maximum value of 1, because multiplying by vector 1, 1, 1 won't alter the original pixel in any way. Let's try it in the shader parameters. So moving to 1 and 1, and we have the original image. Let's just get back to the original zoom and reset the parameters, and the grid is back. And if we control these parameters using a script, we could simulate a smooth transition from a normal display to an LCD monitor, which would definitely fit well with many types of games. Thank you for watching. This time it was pretty quick, wasn't it? I think it's sometimes nice to insert a simpler tutorial between more complex effects to mix things up a bit. Besides, these transformations are very performance friendly, so we don't have to worry about using them even on older setups. Anyway, I hope you enjoyed today's tutorial, and if you did, I'd greatly appreciate every like or subscribe. Take care, and I'll see you again in the next video.